Numerical number 26. A cell supplies a current of 1.2 ampere through two resistors, each of 2 ohm, connected in parallel. So let me draw the circuit diagram first. There are two resistors, each of 2 ohm, and they are connected in parallel with each other. And that combination is connected to a cell. Cell supplies 1.2 ampere current to this circuit. Now when the resistors are connected in series, it supplies a current of 0.4 ampere. So next time we connect these resistors in series, and then series connection combination is connected to the cell. 2 ohm, 2 ohm, and this time the current becomes 0.4 ampere. Calculate the internal resistance and EMF. Internal resistance and EMF. So from the first circuit diagram, we will be able to frame one equation, and from the second circuit diagram, we will be able to frame another equation. So E is equal to I into R plus small r. But what is R? Equivalent resistance of 2 ohm and 2 ohm. And how are they connected? They are connected in parallel. So to find the equivalent resistance, we can use the formula R1 by N, where R1 is 2, N is also 2 here, so 1 ohm. So EMF formula is E is equal to current is 1.2, capital R is 1 plus small r. This is our equation number 1. Similarly, from the second circuit diagram, we can write the equation E is equal to I into R plus small r, where capital R this time is Rs, effective resistance of two resistors connected in series, 2 plus 2, 4 ohm. So EMF is equal to 0.4 into 4 plus small r, equation number 2. Now since the left side of both the equations is same, we can compare them. 1 is equal to 2. So 1.2 into 1 plus small r is equal to 0.4 into 4 plus small r. 0.4 3s are 1.2. Opening the bracket, 3 plus 3r is equal to 4 plus r. So this is 3r minus r, 2r is equal to 1, and hence r is equal to half or 0.5 ohm. So internal resistance we got 0.5 ohm. Now when I substitute this value of small r in equation number 1, we get EMF value, that is 1.2 times 1 plus 0.5, 1.2 into 1.5, and that answer is 1.8 volt. So EMF is 1.8 volt. 27th. A battery of EMF 15 volt and internal resistance 3 ohm is connected to two resistors, 3 ohm and 6 ohm, connected in parallel. So here 3 ohm and 6 ohm are connected in parallel, and this combination is connected to the battery of EMF 15 volt. 15 volt EMF, internal resistance 3 ohm. Find out the current through the battery. Current through the battery, that is total current of the circuit. So once again we can apply this formula E is equal to I into R plus small r. But first let us find out what is capital R. So here Rp is equal to R1 R2, that is 3 into 6 upon R1 plus R2, 3 plus 6, 18 upon 9, that is equal to 2 ohm. So EMF is 15, current is I, capital R is 2, internal resistance is 3. So 15 is equal to I into 5, and hence the current is 3 ampere. Okay, so the current coming out of the battery is 3 ampere. Next sub question is PD between the terminals of the battery. Now this PD between the terminals of the battery is nothing but terminal voltage. So V is equal to I into capital R. Current is 3 and capital R is 2 ohm. So that is equal to 6 volt. So see, out of 15 volt EMF, terminal voltage is 6 volt. That means the remaining voltage 15 minus 6, 9 volt is the potential drop within the cell. C. current in 3 ohm resistor. So to find current in 3 ohm resistor, we should know what is potential difference across 3 ohm. And here potential difference across 3 ohm will be same as terminal voltage provided by the battery, which is 6 volt. Please do not make a mistake here by taking 15 volt as the potential difference across 3. Alright, 15 volt is the EMF, but the terminal voltage is only 6 volt. So PD across 3 ohm is 6 volt, and now we can use the formula V is equal to IR. V6 current we want to find out through 3 ohm, so I is equal to 2 ampere. And similarly, we can find out what is current in 6 ohm. So PD across 6 ohm will also be 6 volt, right? Because that is also in parallel connection with the battery. So V is equal to IR, V is equal to 6, R is also 6, so current is equal to 1 ampere. And then you can verify yourself that 1 ampere plus 2 ampere must be the total current of the circuit, 3 ampere. So that matches with the answer of the total current of the circuit. 28. Circuit diagram in figure shows 3 resistors 2, 4 and R ohm connected to the battery of 2 volt and internal resistance 3 ohm. If main current is 0.25 ampere, find the potential difference across the 4 ohm resistor. Okay, so this 0.25 ampere current will divide into two parts from point A. Once again, those two parts combine at point B and make the main current of the circuit, which is 0.25 ampere, and then that 0.25 ampere current flows through 4 ohm resistor. So to find PD across 4 ohm, the formula is very simple. V is equal to IR. Current is 0.25, or we can say 1 by 4 into resistance is 4 ohm. So that becomes 1 volt. 1 volt. Then we want to find out PD across the terminal, PD across the internal resistance of the cell. So PD across internal resistance is nothing but potential drop. V is equal to I into small r. Current is 0.25. Internal resistance is 3 ohm. So this gives us 0.75 volt as our answer. PD across internal resistance, or in other words we can say potential drop. C. PD across 2 ohm or R ohm resistor. Now see, what is the total EMF of the battery? EMF of the battery is capital V plus small v. EMF is 2 volt. V is the terminal voltage, we don't know its value, but potential drop is known, 0.75. So we can say terminal voltage will be 1.25 volt. Now this terminal voltage divides into two parts: potential difference across the combination of 2 and R, and potential difference across 4 ohm resistor. So 1.25 is equal to V1 plus V2. V2 is 1 volt. 1 volt. So V1 is equal to 0.25 volt. Alright, so PD across R or 2 ohm is equal to 0.25 volt. And once we know the PD across R or 2 ohm, we can say V is equal to IR, where V is 0.25, current is also 0.25 into RP, okay, where RP is the equivalent resistance of 2 ohm and R ohm. So this becomes 1 ohm, RP is 1, RP is 1 ohm. But since 2 and R are connected in parallel, we can say 2 times R upon 2 plus R is equal to 1. So 2R is equal to 2 plus R, and hence R is equal to 2 ohm. So value of R is 2 ohm. Next question. Three resistors 6 ohm, 2 ohm and 4 ohm are joined to an ammeter A and a cell of EMF 6 volt as shown in the figure. Calculate the effective resistance of the circuit. Now as you can see that three resistors here are connected in a network. Okay, there is a network of three resistors. Let me draw that network separately here. 2 ohm, 4 ohm and 6 ohm. This is point X junction point, this is junction point Y. So we will have to find out equivalent resistance between X and Y. There are two paths to go from X to Y. This is path number 1. This is path number 2. Equivalent resistance on path number 1 is 4 plus 2, 6 ohm, because 4 and 6 are connected in series. Now this 6 ohm is in parallel with another 6 ohm. So Rp of this entire network is now, we can say R1 by N, that is 6 by 2, 3 ohm. So effective resistance of this circuit is 3 ohm. And then what is the reading of ammeter? So we can say V is equal to IR, voltage is 6, I is the current, and R is equal to 3. So I is equal to 2 ampere. 30th, diagram below in the figure shows the arrangement of 5 different resistances connected to a battery of EMF 1.8 volt. Calculate the total resistance of the circuit. So you see that R1 and R2 are in parallel, and you would agree to this point that R3, R4 and R5 are also connected in parallel. So let us label the effective resistance of R1 and R2 as R dash, and the effective resistance of R3, R4, R5 as R double dash. Okay, and then R dash and R double dash are in series. So to find out R dash, I can use this formula. R dash is equal to R1 R2, that is 10 into 40 upon R1 plus R2, 400 upon 50, and that is equal to 8 ohm. And to find out R double dash, we'll have to use this formula. 1 upon R double dash is equal to 1 upon 30 plus 1 upon 20 plus 1 upon 60. LCM 62 plus 3 plus 1, which is 6 upon 60. So 1 upon R double dash is 1 upon 10, and hence we can say R double dash is equal to 10 ohm. So now this R dash and R double dash are in series. Okay, so let us draw the circuit diagram for that. This is R dash 8 ohm, that is connected to ammeter. Ammeter is connected to effective resistance of R3, R4, R5, which is 10 ohm, and that combination is connected to a cell which provides 1.8 volt EMF. So effective resistance here becomes 8 plus 10, which is 18 ohm. And then it is easy for us to find out the reading of ammeter. The formula is simple now. V is equal to IR. V is 1.8. R is 18. So I is equal to 1.8 upon 18. That is 0.1 ampere. And finally, we are here on the last numerical of this exercise, numerical number 31. A cell of EMF 2 volt and internal resistance 1.2 ohm is connected to an ammeter which provides 0.8 ohm resistance and two resistors 4.5 and 9 ohm as shown in the figure. So 4.5 and 9, how are they connected? They are connected in parallel with each other. Find the reading of ammeter. So to find the reading of ammeter, the formula is very simple. E is equal to I into R plus small r. EMF is known, yes, 2 volt. Current, no, that is what we want to find. Capital R is also not known directly, so we'll have to calculate R first, and internal resistance is 1.2. So to find capital R, you see that 4.5 and 9 are in parallel. Okay, so Rp is equal to 4.5 times 9 upon 4.5 plus 9. 4.5 times 9 is 40.5 upon this is 13.5, and that answer is 3 ohm. So that RP 3 ohm is in series with ammeter, which provides 0.8 ohm resistance. So total external resistance of the circuit, or we can say R equivalent, is 3 plus 0.8, that is equal to 3.8 ohm. So using this fact now, we can say EMF is I into R plus small r. 2 is equal to I into capital R is 3.8 plus internal is 1.2. 3.8 plus 1.2 is 5. So current is equal to 2 by 5, 0.4 ampere. Alright, current is 0.4 ampere. Then potential difference across the terminals of the cell. Potential difference across the terminals of the cell, which is nothing but terminal voltage. Yes, you are right. V is equal to IR. Current is 0.4. Total external resistance is 3.8. So the answer is 1.52 volt. So terminal voltage is 1.52 volt. And potential difference across the 4.5 ohm resistor. So potential difference across 4.5 ohm resistor is nothing but potential difference across the entire network of 4.5 and 9 ohm. So PD across 4.5 ohm will be same as PD across RP. And what is RP? 3 ohm. Alright, 3 ohm. So PD across 4.5 ohm or PD across RP will be the same. And to find out that PD across RP, we can use the formula IRP. Current is 0.4, RP is 3. So 1.2 volt is the potential difference across the combination of 4.5 and 9. Or we can say same is the potential difference across only 4.5 or only 9 ohm.
Thank you for watching. Please check the link in the description below for more numerical videos. Please like, share and subscribe to my channel.